All righty, friends. So last time we talked about right triangles and how we can use the sine, cosine, tangent, secant, cosecant, cotangent to be able to solve for the sides and the angles we don't know. But sometimes it doesn't work out so nice. I mean, a lot of times we just don't have a right triangle. So say I have something that looks like this. Sometimes I just don't have a right triangle. So we have A, B, C. And mathematicians, a lot of times, if they call the angles capital letters, they make the sides that are opposite those angles the lowercase letters. So little a, little b, and little c. So say I wanted to find the area of this triangle. Well, right now I'm looking at it, I'm going, I know that there's going to be some sort of height here, and I know that the height has to be, it's always going to be perpendicular to the opposite side. So that'd make A my base of my rectangle, or my triangle, but I need to figure out some way to figure out the height. So what mathematicians did is they said, okay, well let's go ahead and see if we can't figure this out. We know this is angle C. We know that this side right here, B, would be the hypotenuse for that. But is there a way we can find out what the height is in terms of B and C? So when they did that, they found out that the area or the height would be the sine of C equals the opposite over the hypotenuse. So that means the height would be the same thing as B times sine of C. So the area of this triangle would be 1/2 A, which was the base, times the height. Or another way to think of it would have been the area of the triangle would have been A times, and in place of H, we plug in B sine C. And all of that is divided by 2. And that turns out that every triangle, we could find the area, and this is actually technically the trig equation to find the area of any triangle, 1/2 AB sine C. But notice that uses this angle right here. The same idea would have worked for the other sides. In other words, B times C sine of A divided by 2 also would have worked. And the area of A times C sine B divided by 2 also would work. Notice, it's always on the AB sine C, it's always two sides and the angle that's in between. B and C sine A, two sides and the angle in between. On the other one, we have A and C, so two sides and the angle that's in between. As long as we know that, we can actually go through and figure out the area of any triangle. Well, what math people realized, they said, okay, well, all these are the same thing. They all equal the same area. So if we set them all equal to each other, each of these areas would have been the same area. So they're all equal to each other. Well, math people, they started looking at the thing going, okay, well, we got a whole bunch of stuff. Maybe there's some way we can combine them. And they saw every single one of these had 2 letters in the numerator and 2 on the denominator. So they said, what if we multiplied everything by 2 times all 3 letters? See if we can't get rid of some of the extra stuff there. And as long as we're multiplying all three of these by the same thing, it should be okay. And when they did that, they ended up creating something that had sine of C over C equals sine of A over side A, and the sine of angle B over side B. Because the A's and the B's canceled out, and the 2 canceled out, leaving us just a C. The B's and the C's canceled out, and the 2 canceled out, leaving us just the A's. And the A's and the C's canceled out, and the 2's, leaving us over B. This thing right here came to be known as the law of sines. And what it says is that no matter what, triangle I know, I can, if I know enough information, I don't need to have a right triangle to help me solve for all the unknown sides and angles. All I need to know is the right information. What's the right information we need to know? Well, law of sines, it works if we know one of two things. If we know two angles and one of the sides. Or it works if we know two sides and one of the angles across from one of those two sides. And we'll get into that a little bit more in a couple days. So two angles and a side. So, or two sides and one of the angles across from it. So that one I think needs a little bit of explaining here. So I got two angles. So say I know an angle and I know another angle and then a side across from it. So if I know those three things, I could solve a triangle. So this is what we're playing with today. This is the law of sines. You can see it right there for you. And it comes from this idea of the area of a triangle. So first part, find all missing parts of triangle ABC. So whenever you're dealing with these, friends, first thing you always want to do is draw the blasted triangle. Yeah? Draw the blasted triangle. And again, it doesn't need to be exact. It just needs to be a triangle. So A, B, C, and then we have our little a and our little b and our little c. And we're just going to add all the things we know. So I know that angle A is 43 degrees. I know angle B is 76 degrees. And I know that little a is 19. So we got to go and figure out everything else. Plus, we're also going to find the area for the triangle. So if I'm looking at this here, I'm thinking to myself, all right, well, angle C I can figure out pretty darn quick, because I remember back in geometry that the angles of a triangle added up to 180 degrees. So if I take that and subtract 43 and 76, I bet I can figure out angle C here pretty darn quick. And friends, I believe it is 61 degrees. There we go. All right, so how do I go about finding the other sides? And this is where the law of sines comes into play. Now, the first thing we always have to do is we have to know a side and the angle opposite that side. So if you notice these two, I know angle A and side A. There's this angle and a side that's opposite. So I have to use that every single time when I'm looking to solve for one of the sides. So sine of 43 degrees, that's sine of A over 19, that's the side length of A, equals, let's do B first. Sine of angle B over little b. So we're going to go ahead and we're going to solve and get b by itself. So we're going to cross multiply and then divide out. So that's just algebra 1. So I'm going to assume you guys are pretty good cross multipliers. You end up with something looking kind of like that, friends. It turns out that b is approximately 27.03176412. Now, the reason why I put all those letters up there is I'm going to go and store them like we talked about last time. I want to store those numbers because 3, 1, even though I only got around to 4 decimal spots, I'm going to store all those because when I go to find the area, notice, when I go to find that area, the area of this triangle, I know this side, I now know this side, and I know the angle in between. I can actually go ahead and figure out that area. So by storing that, and I'd store that as the letter B for me personally. Again, you can store it at whatever you want it to be. I can now go ahead and plug in here 1/2. Still got to find side C. We'll come back to it in a second. But A is 19. So a side, another side, and I save that as B. And the sine of the angle in between. So when I plug that into my calculator, friends, I end up with 224.6039. And I never have to write out all the decimals for area because I'll never go longer than that. Now, if they would have told me a dimension, say like feet or centimeters or whatever, I would have had to add that dimension squared. But when you guys get to calculus, if there is no dimension on that, if there are no units, and there are no units here, if there are no units, we don't have to include any units squared at the end of it. There's no reason. So we have B. Now I got to go back and find C. So we're going to do this again now. Still using that sine of 43. So since I know everything except for C, I don't have to write out all the decimals when I get this answer. I just need to go ahead and figure out what this would be here. Sine of 61 degrees all over C. All right, we're going to cross multiply. Whoop. We have 19 times sine of 61 all over sine of 43. And C would be approximately 24.3663. All right. So there you go. Found it all. All right, friends, why don't you take a look at this next one and see what you can make out of this next one. Go ahead and pause the video and give it a shot. All right, let's see how you did here. I got, whoa, that's a little bit too big. That's awesome. I got angle A was 117 degrees. I got angle B was 93 degrees. And angle C, I don't know, but little b was 67. And I got to find little c, little a in the area. And right now, friends, there should have been bells and whistles going off in your head. Bells and whistles. Because when you went to go find angle C, if you didn't recognize it at first, it's okay. Don't lose sleep over it. But when you went to go plug it in there, you find out that C was equal to -30. And friends, I don't know about you, but I don't deal with negative degrees on regular old triangles. Don't deal with that. So that tells me here, and this is a triangle that doesn't exist. So because of that, I will go ahead and write it in there. So every once in a while, we're going to deal with triangles that they just don't exist. That's okay. No harm, no foul. But sadly, this is not the only weird kind of triangle out there, or weird case out there. Now, friends, let me draw a little bit here for you. Say I have a circle. Inside my circle, let's put our center. Okay, just for the sake of argument. Now, what I want to do here is I'm going to create a triangle. And I'm hoping you guys are okay with my triangle here. It's a decent sized triangle right there for you. And just for the sake of argument, I'm going to give you, let's call it letter A, letter B, and letter C. And what if I gave you the measure of C? Like, I don't know, say C was like 54 degrees. And I told you that little c was 13. And just for the sake of argument here, what if I told you that A was 14? I'm not saying that's what I gave you, but say I did. What if I told you that there might be two triangles that have this exact same information? Here's my 13. Here's my 54 degrees down here. And this side, this whole side right here was 13. Now, friends, I want you to think about something. This side right here, I believe it also equals this side right here. And if I have two sides that are the same, we say that that thing is isosceles. That means that this angle right here equals this angle right here. And friends, we're going to find out in a couple of days that angles that are supplementary, not complementary, we did complementary yesterday, but angles that are supplementary, their sine is the same exact value. I believe if this is 13, I believe that this side over here then also would have to be 13 as well. And friends, by doing that, we have our green triangle. I'll tell you what, I think I had two triangles that had the exact same values. So sometimes I end up with a triangle, no fault of your own. I end up with a triangle that, or end up with given information that could actually represent two triangles. It could have represented this one, 13. So we're looking at 3 right there, isn't it? 14 and 54. And it could have been this one. Could have been the smaller version. These triangles are really, truly not equal to each other. We can tell that just by looking at them. And by the way, friends, you always wondered to know why ASS didn't work to prove triangles congruent in geometry. This is why. All right. But notice what happened here. This triangle right here, this angle is related to this angle right here. It was 180 minus theta. So even though they both set up the same, we can find the two angles or find the two triangles and see how they differ on each other just by looking at what that first angle is I'd find. That first angle I would have found in this problem would have been angle B. And once I find it in this one, if I subtract from 180, I'd figure out what angle B would have been in this one. Everything ends up the same. So how do you tell if you're dealing with two triangles? Some of you right now are going, I don't like these two triangles. This is called the ambiguous case. Now, in order for us, the ambiguous case to happen, essentially, guys, a perfect storm had to happen. Three things had to happen in order for us to get a case that represented two triangles. The first thing we had to be given two sides and one acute angle, one angle across from one of the two sides. The next thing, the given angle had to be acute or less than 90. And the third thing that had to have happened, the first angle we find, which is the second angle, also had to be acute. And friends, if these things happen, if this perfect storm of things happen, then all of a sudden we have the ambiguous case. We have two triangles that are being described. Now, does that happen all the time? No. But you have to be aware of it. Even though using law of science to solve things isn't too terribly difficult, we do have to be aware that sometimes this perfect storm pops up. And friends, that's what's going to happen here. Now, a lot of times on you guys' test, it'll be given to you like this, because we won't tell you if it's the ambiguous case or not. If something doesn't exist, you just write D and E, saying, hey, it didn't apply on this problem. But if it does apply, then we have to go ahead and solve it. So I'm looking at it here. I have my angle, side A, side B, side C. Side A, side B, and side C, or angle A, angle B, and angle C. So angle A was 55 degrees. I know that small a is 9 and small c is 10. So notice, I have two angles, and I know the angle opposite one of those sides, the angle I was given is opposite one of those sides, and it's less than 90. I've already hit two of the three things that could make this possibly be two triangles. So the first angle I have to find is I have to find angle C, because I know what the opposite side is. So sine of C over 10 equals sine of 55 over 9. So then sine of C equals 10 times sine of 55 all over 9. Now, friends, in order to get C by itself, this is where we use our inverse trig. So we're going to use our inverse trig back from integrated 1. So we're going to use the sine -1 button to move it to the other side so we can figure out what that angle is. So we have 10 times sine of 55 all over 9. Now, if this angle ends up being less than 90 degrees, then the perfect storm happened. I'm going to end up with two triangles. But if it doesn't, then we're okay here. So when I plug this into my calculator, friends, I end up getting 62.54494692. Friends, I got the perfect case, which means now, again, two sides in an angle. The given angle is acute. The first angle I found was also acute. Now it tells me I'm going to have two triangles. Now you don't have to draw two triangles for yourself. You don't have to do that. I'm going to, just so we can see it here, because what's going to happen right now is I'm going to leave this one. I'm going to go work on that other triangle. So in other words, I'm going to leave this triangle here, and I'm going to go work on that other triangle. So now, because I'm going to leave it, I need to store it. So we're going to use that store function that we've been talking about quite a bit on this stuff. So I'm going to store this as another variable. Now, for me personally, since I like to use the letters A, B, and C, and I'm going to go deal with a different triangle, I usually call this D. You don't have to. You can call whatever you want to. But I am going to go ahead and store that value so I can deal with it a little bit later. So now, when I come back to it, I'm dealing with a triangle. Oops, see, that's not what I wanted. I'm dealing with a triangle now that looks something like this. And again, it doesn't need to be drawn to scale at all. So I'm going to go deal with that second triangle then. And that second triangle, I need to go and figure out what B2 is. I need to know what little b2 is. I'm going to figure out what this angle is here in a second. But notice all the other information is still the same. Nothing else is going to change over here. It's all still going to be the same. So this became C1, big B1, and I got to find little b1. So that C2, this is where we said that supplement thing. So that angle C2, this is going to be 180 minus C1. So that means C2 then is going to be about 117.455 5 through 1. And again, I'm going to store this value. So for my answer here, I don't need all the values. I'll need to go 4 decimals. Don't forget my degree signs here. But I'm going to store this now. Since that's angle C, I'm going to store that as angle C. So I'm going to hit my calculator, store. So that way I have it. So then I'm going to go find B2. So B2 is going to be 180 minus 55 minus C2. So B2 is approximately going to be 7.544946919. And friends, I'm going to store that one now too. I'll store that one as B. So that was 7. No, that's a really small angle. But again, I don't want to have to keep trying to write that angle out over and over again. So I can just use now big B to help myself out. So sine of that 55 degrees all over small 9. Now I can go find little b. So we cross multiply and solve it. So B2 is sine, oopsies, 9 times sine of big angle B2, which I have stored in my calculator, all over sine of 55 degrees. Which is about, oh, what would that be? 1.442,632,317. If I want that, I can store it. I'll be honest, I'm not going to use it, so not even going to bother storing it. So the area then, so I now know what angle B2 is up here, so I'm going to use that. So 1/2 times 10 times 9 times sine of angle B2. And so I find out that that area right there is about 5.9087. All right, so we finished off this triangle 2, but friends, we still got to go back and finish triangle 1 now, right? So it takes a little bit of time when you're dealing with the ambiguous case. But notice what happens here. Everything I just did, I'm going to do again, but instead of using measurements from 2, I'm going to use the measurements from 1. So over here, the thing I did was I went and found angle B2. Once I knew what C was, I'm going to find angle B1 because I already know what C is. Nothing changes. I just follow the same order all the way down. So B1 would be 62.45505,308. So that means this, and I'm going to save that now. Now notice, even though this is B, I can either choose to do a different letter here. And for some of you guys, you might want to do that. It really depends on you. A lot of times, once I finish triangle 2, I don't care what the letters are, so I go back. And I'll go ahead and use B again. Doesn't matter. If you're really worried about it, pick a different letter. Pick F or G or H or whatever. Doesn't matter. So just to keep things safe, I'll use F. I never use E just because E is a number. And then I gotta use my law of sines here to find out what lower B is. So sine of 55 degrees over 9 equals sine of B1 all over little b1. And notice it's the exact same order as what we did before. It's just we're using the values for triangle 1, not triangle 2, because again, it was the perfect storm that hit. We had the ambiguous case show up. All 3 things were met. And friends, when we plug that in there, B1 ends up being 9.7415797771. So 9.7415. Oops, 6, my bad. My 7 there started looking like a 2. This right here was supposed to be a 7. All right, and then we find the area. So I know what some of you guys are saying, you're going, what the heck? That problem took forever. It does take a little while. I'm not going to lie to you, friends. It does take a little while. However, you guys, as you get better at it, you will be able to go through it a lot quicker. And again, writing with a mouse like I'm doing does not lend itself to be able to write terribly fast. The more and more you do of these, the easier and easier it gets. And that ends up being 39.8992. All right, friends. Why don't you pause the video here and scroll down and see if you guys can try the next one yourselves. Okay. All right, let's see how you guys did here, huh? We're just going, please, please, please don't be the perfect storm. Please don't be ambiguous. Ambiguous isn't too bad, friends, once you get the hang of it. It's rough at first. It's rough at first as you're kind of getting used to the idea. So 43 degrees, A is 12. Uh-oh, it's given two sides. I was given the angle opposite one of those sides, and it was acute. There's two. So already we have two of our categories here for being ambiguous. So what we have to do is figure out then, is this actually the ambiguous case or not? So let's figure it out. Sine of 43 all over 12 equals sine of B all over 15. So we have 15 sine of 43 all over 12. And we do our inverse sine. And if this value ends up being more than or less than 90, that means we are going to have the ambiguous case. So here we go. If it's greater than 90, we're good. But when I plug it in here, I ended up getting 58 point, and it ended up being the ambiguous case again. 4844 0863. So I mean, this right here was 58.4844. So I'm going to store that one again. And again, because it's on the first triangle, a lot of times I'll use the letter D. So I can use the other ones later on. 4844. So I'm going to store that. We'll make that letter D. That means that all of these just became B1, 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 and B1. So big C1 and little C1. Yep. So I stored that, which means now I'm dealing with this triangle over here. So I still have A. And again, you do not need to draw out all the stuff unless you find it useful. If you find it useful, by all means, draw it out. I'm just drawing it out so you guys can see where the new triangles is actually going to be looking like. So that means my B2, that would be 180 minus B1. And that would be 121 degrees Ooh, that's a big triangle. 121.5155914. And friends, I'm pretty sure you guessed by now, I will be storing that one. I will store that as B. So 121.5156. Yep. So then I have that one. Now I'm going to go find that other angle, that C2. So that'd be 180 minus 43 minus B2. And friends, that would be about 15.48440863. And I am going to store that one as well. I'm going to store that as C. So 15.4844. So little c then is what I got to find last. So sine of 43 degrees over 12. If you notice, it's kind of pretty much the same order of things we did last time. And I stored sine C2 as C. I'm going to find little c2 now. So I have 12 times sine of C2 all over sine of 43. And when I plug that one in, friends, I end up with 4.6975. 38727. Six nine seven five. And then the area. Never want to forget the area. And let's see here. I know 12 and 15, so I'm going to use angle C2. I'll use these guys here. I always like to use at least two things that were values I was given, because that'll be the most exact. Even when I'm storing these, they're still saved values. So I like to try to use only one saved value if I can. And the area would be 24.0279. All right, friends. So we finished off that second triangle. We can go back to the first triangle now. So C1 is 180 minus 43 minus B1. And when I plug that one in there, friends, 78.57. I lied. That's a 1. I can't read my own handwriting again. 1559137. And again, friends, I'm going to store that. And we'll call it F again. And now we got to go and find little side C. Whew. You guys are being troopers. I know this one's a little bit longer. It's because there's a little bit more theory involved. We had to get to a point of knowing exactly why we're doing what we're doing. Otherwise, I'm just going to be throwing formulas at you and whatnot. And you'd look at it and say, I don't quite get why we're doing this here and this there. So I wanted you guys to have an idea a little bit, so that way you're not quite so lost here. And C1 is approximately 17.2430732. So 2431. And last and certainly least, friends, let's get our area here. And I know you guys are probably thinking to yourself, yes, you will get an FRQ on having to solve these triangles, friends. So 1/2. So make sure that you practice these as much as possible, because I give you 1 point per blank and then 1 point for the work. So there's at least 9 points here. Oopsies. I mean to do that. Sine of C1. For that, C1 for me is letter F, but still. And so the area then would be 88.1981. All right. Good deal, friends. Good deal. Okay, so now let's try one more little thing here for it. Say that we are dealing with a problem. So go ahead and pause it real quick, see if you can actually draw an example of what you actually see here. All right, let's see what you guys came up with. You're standing 40 meters away. So, and then you have a tree that's lining up going sideways. So that tree is right there. Whoop. And you are 40 meters away. Notice what it says though. It says that it's leaning 8 degrees away from you. So now if I were to draw a tree that's perfectly straight up, it would have formed a right angle. But what we're told here is that it's 8 degrees away from you. So that angle then is actually 98 degrees. So the angle of elevation to the top of the tree is 20 degrees. So let's go ahead and draw that angle of elevation from the feet to the top of the tree is 20 degrees. So let's draw a triangle that represents a problem. So there we go. We have our triangle. And I'm trying to figure out what the height of this tree is. By the way, friends, if we were to draw this a little bit cleaner, I think we'd find something that looks kind of like this. We have 20 degrees. We have 98 degrees. We have 40 meters. We have our height, and we're almost all set up here to figure out what this value is. Because if you notice, this 40 meters, I know, that's going to be opposite this angle right there. So if I want to find that angle, that's going to be 180 minus 20 minus 98. which is going to be 62 degrees. So now I know an angle and a side opposite, and the side that's, or the angle that's opposite the side I'm trying to find is 20. So we can go ahead and do a quick law of sines problem and find out the length of the tree. So sine of 20 over h equals sine of 62 degrees over 40. And if we cross multiply 40 times sine of 20 degrees all over sine of 62, we'll find out that h is about 15.4945 meters. So that is almost, friends, that's almost 50 meters right there. That's a pretty good size. Actually, yeah, it's a pretty good sized tree right there. All right, I'm sorry, almost about 50 feet tall. It's a pretty good sized tree. So, all right, friends, good luck, and we'll talk more about this tomorrow, and I hope you have a good night.